Hi, I'm Miss Hearn. Let's get started.
Let's talk about median. Remember, we're talking, the overarching topic here is measures of center. We spent a lot of time on mean because it involves a lot of calculation, also because we're going to use those calculations to do other things later. Median should be fairly quick. Median, mean, median, and mode are the three most common ones. We talked about mean, now we're doing median, which is the middle value if you list out all the data. So it's going to involve writing the data in order. The symbol we use for median is x tilde. So it has the squiggly bar over the top, the tilde mark. Nice thing about median is it's not affected by extreme values, meaning that the mean takes into consideration all the values. Let's say that all the values in a data set were tiny numbers like 1 through 10, but then there's one data value that's 200. Then the mean can get thrown off by that, whereas the median does not. So it's useful to look at the mean and the median to see if maybe some extreme values are throwing anything off. The procedure is step 1, rank the items. We use the term rank to mean put them in order. If the number of items happens to be odd, then the median is the middle number. If the number of items is even, then the median is the mean of the two middle numbers. The challenge is to find the position that is the middle, because if you have a small data set, it's very obvious. If you only have 3 numbers, the second one is the middle number, right? But if you have 150 numbers, you need to figure out in what position, or let's not use 150 because that one's too easy to do in your head. But let's say we have 133 numbers. Figuring out which number is the middle position is going to be the challenge. So we rank them, we find the middle number, or if it's even, we find the average of the two middle numbers, the mean. But the position of the middle is the important thing. Okay, so as a relatively simple example, we have 10 students in a math class, the same data we looked at before that we found the mean. Remember the mean turned out to be 2.9, by the way. Let's see what the median turns out to be. So in order to find the median, the first step is what? Rank the data. So put them in order. All right, in order to put them in order, we're going to have to start with the smallest, and I want to make sure I don't miss anything, so I'm going to cross it off as I go. So we have 1 and 1. It looks like that's all
the ones, and 2, and 2, and 2, and 3, and 3, and 3, and 4, and 6, and it doesn't look like I missed any. Yay. Let me count just to be sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces of data. Good. Okay, so if there are 10 pieces of data, n equals 10. This is an even number.
Where do you think that the middle is? Okay, so half the data is here and half the data is here. There are 5 pieces of data here and 5 pieces of data here. So in the middle is what I'm going to refer to as the 5.5 position. Okay, we want the data value that's right between the 5th position and the 6th position, but there isn't one, of course, so we add them together and divide by 2. 2 plus 3 over 2, 2.5. Good. So this is the actual median value. Now remember, the mean was 2.9. Why was the mean a bit higher than the median, do you think? Yeah. This larger 6 over here, which I wouldn't call an outlier, I mean, it's pretty close to the rest of the data, but still, it really kind of pulls the mean in one direction. So the mean is very sensitive to extreme values, whereas the median is more resistant to extreme values. So that's why it's good to look at both. Okay, now in that example, it was not very difficult to figure out the middle. because there were only 10 pieces of data. But when there's more than that, this is a very solid way to figure out the position of the median. This is not a formula for the median. This is a formula for the position of the median. So for example, it's n plus 1 over 2, or remember n is just the sum of the frequencies. So for example, in our last example, let's go back. Okay, if I find n plus 1 over 2, what is that going to be? That is 10 plus 1 over 2, right? The number of pieces of data is 10. 10 plus 1 is 11 over 2, which is 5.5. This is the position of the median. What position did I say it was in? The 5.5 position. What does that really mean? It's between the 5th and the 6th position. That's all that means, okay? So when you need to find the position of the median, you take the number of data values, add 1, and divide it by 2, and you get the position of the median. Of course, you are not done at that point. You still have to calculate the median because this is just the position. All right, so at your desk, try this one. I want you to calculate, use the formula n plus 1 over 2 to find the position of the median, even though you may be able to spot it right away, just to show you that it does work. Find the position of the median and find the median. Okay, so let's take a look. First, sort it in order, rank it. So is this what you got when you ranked it? 0.42, 0.48, 0.66, 0.73, 1.10, 1.10, and 5.4. Okay. Then we're going to calculate n plus 1 over 2. So how many data values are there? 7. So 7 plus 1 is 8, divided by 2 is 4. So that tells us that the position of the median is 4. So the number in the 4th position is 0.73. All right, notice that there were an odd number of pieces of data. So when you add that 1, you get an even number that's divisible by 2. That tells you that your median is actually going to be one of the data values. All right, on the other hand, in this data set, where we only have 6 numbers, we end up with a median that is between 0.73 and 1.10. So when you have a data set with an even number of values, you add 6 plus 1 equals, so that's the 3.5 position, right? So in this position, there's nothing because we need to average the 3rd position and the 4th position. So that's why I added 0.73 plus 1.10 and divided by 2. Okay, so the median turns out to be 0.915, not actually a data value, and that's okay. All right, how would you find the median if you're given a frequency distribution? So you do not have to list them out, but listing them out is not wrong. I mean, that would work. But the problem is, what if we had like a frequency of 42 and a frequency of 89? You don't have to list them out. So there is a simpler way. Do you remember when we talked about the cumulative frequency distribution? What was that? Add each one up, that's right. We're going to use the cumulative frequency distribution. First, we're going to find the position. How do we find the position in the list? All right, what do? We add up the frequencies because that's our n. We add 1 to it, and we divide that by 2. So where is this coming from? If you add up this column, you should get 23. Let's see, 7, 9, 15, yeah, 23, okay? So add up the frequencies, add 1 to that value, and divide by 2, and we see that our median is supposed to be the 12th piece of data. Now, as you just mentioned, I could list out each of the pieces of data and find the 12th one. I have a 1 that appears 4 times. I have a 2 that appears 3 times, but this is going to take a while, right? We're only up to the 7th. We need the 12th. So instead, especially when you have larger frequencies, what we're going to do is we're going to use our cumulative frequency distribution to find it. So I am going to, remember how we did this? The first category brings us up through 4 pieces of data. Add 3 more, you get 7. Add 2 more, you get 9. Add 6 more, you get 15. Add 8 more, you get 23. Do you remember us doing that before? Okay, so we're just adding the number of pieces of data up so far. So what that means is that really the first through the 4th pieces of data are 1s, right? And then which pieces of data are 2s? The 5th through the 7th are 2s, right? Are you with me? And then which ones are 3s? 8th and 9th, yeah. And then which pieces of data are 4s? The 10th through the 15th. And which pieces of data are 5s? The 16th through the 23rd. That's what this cumulative frequency distribution is telling us. It's telling us their positions in the list. And what are we looking for? The 12th item, right? So in which category do we see the 12th? 10th to 15th, yes. So we see that right there, the data items in the 11th, 12th, 13th, and 14th, and 15th positions are what value? 4s, right? Remember, this is X, this is the data value. They're all 4s. So that means that our median is 4. Does that make sense? Okay, so that's how you find a median when you're given a grouped frequency distribution, or in other words, a class frequency distribution.
I hope you found this video useful. If you did, please remember to like it.